Okay, so chapter 12 is heavily based around statistics, and it feeds into our statistics project. So this is kind of similar to what we saw with finances, where finances led into our mortgage project. This one is going to lead in, these sections are going to lead into that statistics project. And so this section's pretty heavy on definitions, but they're important definitions because I believe about half of the questions asked about somehow what sampling is or what your frequency distribution or what graphs are. Okay, so as far as definitions go, if we're talking about kind of doing a survey, and that could be a survey of asking people questions, or that could be just looking at like items in a bin and kind of recording the colors. The overall thing that we are surveying from is called the population. So, for example, when we were doing this project before COVID, people were asked to ask people on campus questions. And so, even if they were kind of asking questions at, let's say, just the Tivoli, the idea was that the population was CU Denver students, or I guess more accurately, students on Auraria campus. And same type of thing with, like, I guess the pulling balls out of a bin thing. You maybe only pull out 5 of the balls instead of looking at all of them. And so the population is that entire bin or basket or whatever they're in. And so what a random sample is exactly what I was just describing. That isn't kind of the big piece. So random sample is kind of a part of the whole. The population is the whole. So again, the people that were asked on campus survey questions, that's the sample. So that's not all of the people on Auraria. There's no way anyone in my class last year was able to ask everybody on campus a question. Only the people that they were actually able to talk to were the random sample. And same thing with the balls in the bin example. Unless you pulled out every single ball, which I actually believe that would still be a random sample, but typically you wouldn't do that. You would only pull part of them, then like the 5 that you pull out are your random sample. I'll close my window real quick. And so those are questions that I believe come up on the project of identifying what your population is and identifying what your sample is. And it's going to become more important with this project because it's going to be a little bit different. You're not going to be able to go on campus and ask people questions. I suppose you technically are, but I wouldn't recommend it because it might not be super safe. So for an example, we have hotel owners kind of doing some statistical analysis on people in their city about their opinions of casino gambling. And so the population in this case is the entire city. And there's no way that they're going to be able to ask everyone in the entire city, but that is the population. That's what they're pulling from. And then one of the hospital owners suggests obtaining a sample by surveying all the people at 6 of the largest nightclubs in the city on a Saturday night. Each person will be asked to express his or her opinion on casino gambling. Does this seem like a good idea? And this lengthy B question is kind of one of the heart of the questions in this statistics project. So with the mortgage project, the big picture question was, is buying a house good? Or I believe, is buying a house good for you? Why or why not? Please provide 2 examples. And so I wouldn't say that's the end all be all question, or this is the end all be all question on the statistics project, but it is a very valuable concept. And this is introducing this type or this concept of bias or sampling bias. And that's the short way to think about it, is that it's really hard to create a survey or some sort of sampling that isn't biased. And in fact, there's kind of a whole concept and a lot of papers about how to do this with double blind studies, and is even that some sort of bias. So one way to think about it, and this is certainly an oversimplification, is that almost any survey you're going to do is going to experience some sort of bias. And so this is a good example because the bias is pretty straightforward. So the owner is asking here, all people at 6 of the largest nightclubs on a Saturday night. That is not not very indicative of the city at a whole. I guess maybe if every single person in the city goes to a nightclub, it's not a bad strategy. But I imagine that's not the case. It's certainly not the case in any town I've ever lived in. And so someone's going to ask this survey, and it seems likely that the people who are out Saturday night at nightclubs are probably going to be more likely to gamble or like casino gambling. And so, with that in mind, they're going to get their survey results, they're going to make observations about the results, and their observations are going to be biased because they didn't sample very well. But even if you are super careful about sampling, there's going to be some sort of bias. So I think there's a question on the survey or on the project that says what sort of bias is there in your project, and people kind of start to lean towards there is none, but that's not really possible. Again, it technically is possible, but I would be very surprised if anyone could pull that off. And so look for that. To go back to what people were doing last semester, some people said, okay, I was at the CCD Confluence building, and to try and avoid bias, I just asked every fifth person who left the door. And I was extra careful to make sure the timing was correct. So I asked people in the morning, in the afternoon, and at night. And so all of those things are really good ways to avoid bias. But the truth of the matter is, you only ask people at Confluence building. So if you ask people a question about whether or not they're taking a math course, you're going to get heavy bias on that because the Confluence building was where all the math classes were held. Well, not all of them. A lot of the math classes were held. So I encourage you to kind of dig deeper. Yes, if you are super careful, you might get very close to not having bias, but make sure you sit back and think about how you sampled. We're going to talk about possibilities, but maybe you sampled by posting your survey on Facebook. And so that seems kind of random, but that's not true. You're only surveying people that are your friends. And so there's an example of bias right there. So I was a little bit rambly, but that's the idea. That's one of the big pictures and understanding of, on your end, how is your statistical project bias, and then once you start to look at the world and see what their statistics or their sampling or their survey is getting, can you identify the bias that they're having, and is it big enough to be concerned or to cause concern? Okay, so now we have some examples of what might be the best way to, or one of the better ways to avoid this bias. So we have a couple of options. Randomly survey people who live, the question. We return to the hotel owners in the large city who are interested in how citizens feel about casino gambling. Which of the following would be the most appropriate way to select a random sample? Keyword there is random. Random is a very important, or a big goal with statistics, but it's so hard to achieve that even computers can't really randomly generate a number from 1 to 10. It's super hard. And so, yeah, back to the question, people are learning, or they want to learn information about whether or not people like casinos or how they feel about casinos. So one of the options, randomly survey people who live in the oceanfront condominiums in the city. Survey the first 200 people whose name appear in the city's telephone book. C, randomly select neighborhoods of the city, and then randomly survey people within the selected neighborhoods. So for A, randomly sampling people who live in the oceanfront condominiums, it seems like there's probably going to be a bunch of rich people there, and I don't really know which case is true, if rich people like gambling a lot or if they hate gambling a lot in general. But regardless, you're only getting a very certain population when you do something like that. So there's that bias right there. Survey the first 200 people whose names appear in the city's telephone directory. This is a very classic example of something that seems like you're avoiding bias because you're quote unquote randomly just picking the first 200 people, but that's very specific. That's probably all of the people with A's in front of their last name. And that's not to say that like people with A's at the beginning of their last name are biased towards gambling, but that's certainly a heavy bias, especially if you change your question to just be like, what's your favorite letter? That's probably going to be a huge bias. So avoid that kind of, oh, I'm only going to ask the first 10 people from this, or I'm going to look up 10 people in my friends list and I'm going to pick the first 10. You're going to get that bias of those 10 people will probably have very close, I forget how they sort it, first name or last name. And now C is a good example of arguably as random as you can get. You just randomly pick a neighborhood. You're not going to try and pick necessarily oceanfront condominiums. You're not going to try and pick apartments downtown. Just randomly choose it and then randomly pick people to take your survey in the neighborhood. And so this is kind of the ideal case of how to make it so that your survey isn't biased, but that's very ideal and very hard to actually achieve, to randomly select a neighborhood and randomly survey people. That's heavily theoretical. And sure, if you find a way to do that, then I'm fine with you arguing that your survey isn't biased. But outside of that, that's deceiving. It seems like it's simple. Oh yeah, just pick a random neighborhood, pick a random person, you're good to go. That's not super easy to do. That's a very difficult thing to do. Okay, moving on past definitions and past bias. So this is a frequency table. So this is important on the project. It asks you to do frequency tables for both of your questions and what your relative frequency is. And so we kind of use frequency tables because it has the nice ability to quickly record results. And so again, if you're doing surveys in person, you don't want to say, okay, wait 1 second, I need to add up my amount and add it to my new total and rinse and repeat. It's a good idea to kind of break things down to possibilities. So in this case, we have test scores. It seems like we're grouping it by every 10%. And then once someone answers, oh, I got a test score of 62, just put like a tally mark on that. And keep doing that until you're done with your survey. Once you've asked, I think there's 40 people being surveyed here. Once you've asked all of those people, then you can go later on and kind of count up your tallies and count up your relative frequency. And so the tallies aren't too difficult here, or the number of students isn't too difficult here. We just count up the tallies. And then relative frequency is just talking about a percentage. So how many people got 70 to 79? That's 27.5%. How many people got 40 to 49? You take your number of students, you divide it by the total amount of people surveyed, which you could either find by adding all of the number of students on your frequency thing to the left of relative frequency, or you could just take my word, there's 40 people being surveyed, and then timesing it by 100 because you want a percentage. And so this is another thing that we will discuss during the introduction of this project of what is a good frequency kind of tolerance, I guess is the right word for it. And what I mean by that is you could potentially make a frequency table of tests that are students who got from 0 to 50 and students who got from 51 to 100. And sure, that's a table, and definitely you can find a frequency and a relative frequency for that table. The issue is you don't get a lot of information. So you want to kind of shoot for an in-between gap of, I'm not going to record every single score and then make a frequency table for every single score and then talk about the relative frequency, because then you're kind of getting lost of what information is really happening. Where is the majority of scores? Are they C's, are they B's, or D's? Or on the other side, kind of making those too big of a range on your frequency, like 0 to 50 and 50 to 100, because then you don't get a lot of information. You're either going to say, oh, everyone's below 50, everyone's above 50, but you can't really know how many people passed or what their score was or something like that. So that's something to be aware of on your project as well. Here is a histogram, and a histogram is a fancy name for a bar graph. So if you've done bar graphs before, you've done histograms before. And so I think in the past I didn't even really go over histograms before the project because I think the majority of people have seen them, but it's not worth, or it's worth discussing. It's worth a discussion. Briefly discussing just so everyone's on the same page. And so to build a histogram, in this case, you could have a range if you wanted to, like we did in the last problem. You just have to clearly label that on your histogram. Or in this case, we have maximum yearly growth, so how fast are boys growing. And so it's not a bad idea to have year by year because there's only so many options. And so we'll start to kind of bunch into categories. And so to build a histogram, you just label the bottom with the amount of people or whatever you're being surveyed about. So if you're being asking how many people like or what are people's favorite fruit snacks type, you could have Gushers on one of them, and then you could have Welch's on another one, and you could have Mott's on another one. And those are your bottom things on your graph. And then the biggest difference between a histogram and a bar graph is a histogram has to have on the vertical side how frequent something's happening. So we can't kind of say, okay, fruit snacks to amount of fruit snacks or flavors in a fruit snack or something like that. It has to be how many times something's occurring. And so make sure you're labeling your graph. Every graph needs a title, so boys' age of maximum yearly growth. Every axis needs to be labeled, and then you need to be labeling your points on that. So that is something I'm going to hammer home, and that is something that I'm going to take points off pretty heavily, because if you don't label a graph, I don't know what you're talking about. And so that's all that's happening in this graph. And then you can kind of see the tallest bar is at 14, which makes sense because if you look at the table, there are 9 people or 9 boys who met that amount. And then 10, 17, 18 are the lowest, which also makes sense because there's only one boy who attained the age of maximum, or who grew the most when they were 10 and grew the most when they were 17 and grew the most when they're 18. So that's also something to be aware of, that when you are drawing your graph, make sure you know what the maximum amount is, because if you don't make your graph tall enough with the maximum amount, you're going to kind of have to erase and reset. Okay, stem and leaf plot honestly isn't used a whole lot because it's a way of organizing information. It's just not super, not useful is the word, but it's not a tool that we can kind of apply somewhere else. And so what I mean by that is, with a frequency table, we can look at that, we can find a relative frequency, we can use this to find our mode, we can use this to find our median, we can use this to find our mean, and we can use it to build a histogram. Where a stem and leaf plot has value because if you spend some time, you can kind of figure out the median, but there's not a lot else to take from it. But that being said, it is a way to kind of organize your information. So maybe you can say, I have a lot of things in the 40s digits or the 70s. And so that's how you do it, is typically it's geared towards 2-digit answers, 2-digit results. And so if I have in my survey, I think, let's say this is test scores again, because that makes sense. Let's say I had 47, 45, 43. In my stem and leaf plot, my stem would be 4 for the 40, and then my ones digit, the 47, 45, and 43, that's what goes in my list. And so that's what's happening on this chart. I don't think we do this in the project. There might be a question on my math lab about it because, it's my math lab.